the first of my introductory question exemplars for you. So here we have a stone of mass 0.10 kilos. Let's write that down. Attached to a piece of string, whirled around at a constant rate in a horizontal radius of 0.75 meters. And we have 2.5 revolutions every second. So that's 2.5. That's the frequency is what I'm trying to say. So we know the mass, we know the radius, we know the frequency. And part one of our question wants us to deliver the angular speed of the stone. So we need a relationship that connects the angular speed or angular velocity to what we know. And we know they are related by the frequency. We know omega equals 2 pi f. So omega equals 2 pi f. See if we can put that back where it belongs. Okay. So omega equals 2 pi f. We stick in our numbers there then. We have equals 2 times 3.14 times f, which was 2.5. So that gives us 15.7. We're looking at 2 sig figs. So we're looking at omega equal to 15. Sorry, 16. Radians per second. To 2 sig figs. So just want to make that bold. If I could do that without hiding everything, but I can't. Never mind. We'll just do it then. So 16 radians per second. Then part 2, the orbital speed of the stone. Of course, this is A1 and 2. Stick an A in there if we can. So A2 then, we know that V equals R omega. That's going to be our connection between the linear speed, V, and the angular speed, omega. So we've got radius of 0.75 and we have an omega of 15.7. Now I would use the 15.7, not the 16, because we'll lose some of the precision of our answer and possibly fall outside tolerance if we use the 16. So 0.75 times 15.7 gives us 12 meters per second, which is fine, 2 sig figs. Okay. Then we've got B part 1, which says in order to move in a circle, the stone must be subjected to a centripetal force. Calculate the magnitude of that centripetal force? Well, we've got everything. We've got m, v, omega, everything. So let's use F equals mr omega squared. We could have used mv squared over r. So F equals the mass, which we said was 0.10, times the radius, which was 0.75, times omega, which we said was 15.7. And we're going to square that. So there we go. And that gives us 19 newtons again for two significant figures. And then part 2, what provides a centripetal force? Well, of course it is the tension in the string. So there's our first exemplar.